Hello everyone, I'm Shashank from section AA. Today I'm going to take you through an extremely interesting topic from the DA subject, which is called 3-SAT problem. Now, before diving into the actual topic, let me start with a simple question. Have you ever tried solving a puzzle when you need to figure out something? Right? You had solved some puzzles at any time, right? So, for an example, imagine you're trying to switch on a device. It only works if all three switches are set properly. If you keep turning on and off until the switch finally lights up. That process of trying to find the correct combination, which is exactly the basic idea behind the SAT problem. That's the basic idea. The 3-SAT specifically deals with something called Boolean logic. What is this Boolean logic means? It is based only on two values. Either we use true or false. That's it. Just like if you switch on a light, it just ons or offs. That's it, right? Not more than that. This topic may look mathematical at first, but it has very important real life applications. The slide mentions things like automated circuit checking and hardware testing. Let me simplify that for you. When companies design electronic chips, they need to verify whether the circuit will behave properly or not under all circumstances or conditions. Testing manually everything is not possible, right? So, this SAT solvers check millions of conditions automatically. It is also used in many other ways. We'll be knowing it further in the slides. Okay, in today's presentation, I'll explain everything from the basic and I'll try to understand you. Okay, firstly, let's go into the topic. First a second. Okay, if you see here, it's the introduction to Boolean satisfactorily. Okay, you're getting it. Now let's understand SAT in the simplest possible way. The SAT stands for Boolean, you already know, but what does that even mean? Let me break it into simple. Is there some way to assign true or false to variables such that the entire formula becomes true? Think of it as solving a condition. Imagine your teacher gives you three conditions and tells you you will only pass if all the three conditions will satisfy, right? So, in SAT, the conditions are expressed using logic symbols like OR. OR, this is the symbol of OR where I placed my cursor, and is something like this, and this symbol is called NOT. Look at the example here. Here it states that A or B and not A or C. Let me simplify it for you. The first bracket says A or B. The second bracket says not A or C. Is that clear, right? As I said before. And means both brackets must be true. So SAT asks us, can we find values for A, B and C that make both the brackets true at a time? That's the thing we need to see here. This is just like trying different combinations until everything works out. SAT is actually the base of for many advanced things in computer science, like logic circuits, problems, automated verification. Let's see a small problem here. Just a minute. Here, if I write a problem. Okay, what does this tell? A or B and A not and C. Is that clear? Or C. Okay. Here, what I'm trying to tell is A is equal to false, B is equal to true, C is equal to true. Check the first part here, A or B, right? The first part is A or B. In A or B, if you look at this properly, A or B is equal to false, false or true is equal to true. In the second part, A not or C is equal to true or true or true or true is equal to true. Are you getting? Both are true, whole formula becomes the true. Is like this it works. I think I'm clear. I'll just remove this. I'll just hide this off. Okay, now let's go into the next slide. Let's see what a basic terminology states here. Now coming to the basic terminology. Here. Okay, before we understand three-sat problem, we must learn few basic terms like literal. A literal is a simple a variable or its opposite. So A and not A both are literals. You can think of it like A is equal to you telling the truth, not A is equal to you are telling lie. Both represent the same person but with opposite actions. Next, coming to the clause. As you can hear, clause. Clause is a group of literals joined by or. For example, A or B or not C. This means at least one of the items inside must be true. Just like if we say you will pass if you complete any one of these tasks. Okay, understood the clause. Next is CNF, which is also a conjunctive normal form. This sounds complex, but it's very simple than this. CNF is when multiple clauses are joined using and, like saying you must pass all the subjects to get promoted. Each subject is like a clause, and means you must satisfy all of them. Example. For example, you can see that like A or B and not C or D. That's the example for this. Satisfiable formula. A formula is satisfiable if you can find at least one assignment that makes it true. It doesn't matter if many assignments fail, even one successful case means the formula is satisfactory. Okay, I think these four basic terminology are clear. These are simple ones. Now let's look at another one. Okay. What is a three-sat problem here? If you now come to the heart of the topic, the three-sat problem. Three-sat is just a special type of sat. I told you about the sat, right? The only difference is every clause must have exactly three literals. Why 3? Because this version is widely used for testing algorithms. It is complex enough to challenge competitors across for testing algorithms and structured enough to for real problems into it. Many more. Look at the example on the slide. What it says, A or B and B or C. Each bracket has exactly three elements if you look at it correctly. So clauses can be A, not B, C. Am I correct? A, not B or C. And the entire formula joins these clauses using AND. Our job is to find true/false values that make all clauses true. We are basically solving a logical puzzle, as I said in the beginning, just like a puzzle. Okay, I'll just show you a normal example here. Just a minute. I'm just removing it. Okay, here I'll show you an example here. Here A or B. I'll take here A or B. Oh, I'll take B, not B. A or not B, which gives you or not C. Now tell me, is this a valid clause? Yes, it's a valid clause because it has three literals. All the three literals are here clear. That's why it's obviously a clause. Okay, I hope I'm clear with this slide. Now let's look at the importance of 3-sat. Just a minute. Now let's talk about why 3-sat is so important. 3-sat is one of the most famous problems in the computer science because it's NP complete. Let me explain NP complete in simple language. Imagine you have a puzzle that is very easy to check once someone gives you the answer, but extremely hard to solve from scratch, right? That is NP complete. 3-sat is important because many real world tasks like scheduling, designing circuits, routing verification all can be converted into 3-sat. This means that the solving 3-sat helps solve many problems indirectly. 3-sat is used to measure how powerful or efficient an algorithm is. Modern SAT solvers used in AI depend heavily on 3-sat problems. Am I clear about this 3-sat, importance of this 3-sat? And why is 3-sat important means we can tell that because many real world problems can be converted into 3-sat and it helps measure algorithm complexity. Next, move on to the next slide. Okay. Let's look at logic constraints in 3-sat. Logic constraints. In 3-sat, each clause must have exactly 3 literals joined using OR, and all clause must be joined using AND. Let's take example clause from this slide. A or I gave here A or not B or C. The truth table shows all possible combinations of A, B, C, whether they satisfy the clause. The clause becomes false only when all 3 items inside fail. That means are false. So false or false is equal to false. That's clear, right? False or false is equal to false. Any true anywhere makes the whole clause true. This idea is very important. It helps us see how assignments affect the formula. Now let's look at the basic problem. Take a pencil here. Okay, I'll just, if I take a, okay, I'll take the same example here. 1 minute. here see that a or not b or c. Here if you say example, I'm solving this example clause which is there in the ppt. You can see here a is equal to false, where not b is equal to not 1, which is equal to 0, which gives us the answer of false. C is equal to false, everything is false, then the clause becomes false. This clause is false. Getting that? This is the simple problem, simple example. Now let's see our last slide. Now it's the last slide of this concept. Now let's see solving the 3-sat problem. Okay, there are several methods to solve 3-sat problems, each with different strengths. Let's look at some of the methods. Like first is brute force method. This is the simplest but slowest method. We all try all possible true/false combinations. For small problems it's okay, but for large problems it's extremely slow because combinations grow exponentially and it becomes less effective. Now let's see the second method, which is efficient algorithm, DPLL algorithm. This algorithm which I mentioned there uses recursion and backtracking. It eliminates possible assignments early, so it doesn't check even everything blindly. Walksat algorithm. This algorithm uses guessing and logic improvements, kind of like adjusting things until everything becomes true. And the third and last is modern SAT solvers. These are powerful computer programs. These are most powerful among this all. In AI and verification systems, they can solve even huge SAT problems efficiently. That is clear, right? Okay. Just normal question, like if someone asks like why is brute force method slow, you will be answering like because the number of possibilities grow exponentially as variables increases. That's why brute force is slow among all of them, right? Now this brings us end of this presentation. I hope I explained and help you understand the SAT and 3-SAT, their importance in modern computing. I hope my topics are clear. I think I have explained well. And next topic is the real life examples based on this. This real life example will be covered by my friend Shanmukh in the next slide. So thank you everyone.
Circuit verification. Now I explain how 3-set is used in checking digital circuits. Every digital circuit is made from logic gates like AND gate, OR gate and NOT gate, and each gate can be written as Boolean equation. So the whole circuit can be written as one big Boolean formula. Circuit verification means for every possible input, the output of the circuit should be correct as per the design. We convert each gate into classes and combine them into a 3-set formula. Then we ask the set solver, is there any input that makes the circuit gives a wrong output? If the formula for wrong behavior is unsatisfiable, then no input can break the circuit. So the design is correct. If it is satisfiable, the solver gives one input, example which show as work. Checking digital circuits. Every digital circuit is made from logic gates like AND gate, OR gate and NOT gate, and each gate can be written as Boolean equation. Hardware design testing. Now we move from small circuit to full hardware design like processors and controllers. Uh, these designs are written into hardware languages like Verilog or VHDL tools. Tools convert this design into Boolean expressions and then into CNF. So a three-set solver can test it. For example, a rule like signal A and signal B should never be one at the same time. Can be written as negation of A and B, which is the same as negation A and B. The solver check if this rule is ever broken. If a breaking case exists, the solver finds it and shows an error. If not, the design satisfies that rule. This helps to catch logic errors early. Save redesign cost and improve cheap reliability cheap reliability before manufacturing. Written into hardware languages like Verilog or VHDL tools. Hardware verification concept. Hardware verification means checking if a chip or a circuit always follows its specifications. Every part of the circuit like gates and flip-flops is written as Boolean equations. These circuits are these these circuits are like the every part of the circuit like gates flip-flops is written as Boolean equations. These circuits are converted into CNF and gives to a three-set solver. The solver checks if there is any input that gives a wrong output. If no such input exists, the design is logically safe for the specifications. If an input exists, the solver gives that input as a counter example for debugging. For example, for AND gate with inputs A and B, outputs A, we write C to A and B. This can be converted into CNF class like with negation C and A, negation C and B, and C and negation A and negation B. If no output breaks this class, the AND gate works correctly. Verification means checking if a chip or a circuit always follows its specifications. Every part of the circuit like gates and flip-flops is written as Boolean equations. These circuits are like the every part of the circuit like gates flip-flops is written as Boolean equations. These circuits are converted into CNF and gives to a three-set solver. The solver checks if there is any input that gives a wrong output. If no such input exists, the design is logically safe for the specifications. If an input exists, the solver gives that input as a counter example for debugging. For example, for AND gate with inputs A and B, outputs A, we write C to A and B. This can be converted into CNF class like with negation C and A, negation C and B, and C and negation A and negation B. Hardware verification process. Now let us see the hardware verification process step by step. First step, design representation. The hardware is written in Verilogger or VHDL, which describes how the circuit should work. Step 2. Logic translation. Tools Tools translate this HDL design into Boolean equations for every gate and connections. Step 3. Conversing to CNF. These Boolean equations are changed into CNF form, which is suitable for set and 3 set solver. Step 4. Constrict and encoding. Extra rule like timing, uh, power limit, safety conditions are adding as more logic construct. Step 5. 3 set solver execution. The final CNF is given to a set solver. If the result is unset, no input breaks. The the rules so the so the design is correct for those properties. If the result is set, then input that caches an error, and the case is used to fix the design. Verification process. Now let us see the hardware verification process step by step. First step. Design representation. The hardware is written in Verilogger or VHDL. Importance of 3 set is very important in hardware verification because it helps make cheap reliability before they are built. It helps find facility logic, bad signal combinations, and unwanted instructions before gates. Even in every large designs, these reduce time and money spent on physical testing and makes debugging faster. Since the solver gives extract falling cases, big complaints like Intel, AMD, and NVIDIA use these methods for cheap verification. So the 3 set works like the mathematical backbone of modern automated hardware verification. To end my presentation, 3 set is not only a theory topic but also a powerful tool used in real hardware for circuit verification and chip testing by converting hardware design into problem on this slide. How do we ensure a hardware circuit always behaves according to the uh, specifications? The solution is convert every part of the circuit into Boolean equations and verify use set. Represent each gate logically. For example, AND gate A is equal to A and B. C is equal to A and B. Why this step? Because a uh, because uh, because a because a circuit cannot be tested directly by a mathematical solver, but the equation can convert Boolean into CNF. Boolean CNF. CNF means a big and gate of multiple or classes. CNF is the stand format recursion set solving. For example, CNF negation C and A and negation C and B, negation C and negation A and negation B. Why CNF? CNF. Solver use CNF because it is informed, structured and computationally effort efficient. Sir. Use set solver. The set solver tests every possible assignment internally. We don't manually test anything. If solver finds no violating input and set, hardware is correct. Final verification. If no wrong output is possible, the hardware is logically sound. Hardware verification ensure correctness, correctness before manufacturing, avoiding the risk of facility chip. Now let us deeply understand entire hardware verification process with a problem-solving approach. So let us see that. How do we verify a full hardware design step by step from HDL code to unset result? Design representation. We we sorry. We begin with HDL code, VHDL code. This code defines a gate connect, gate connections and behavior. Because set cannot be read HDL directly, it only understand logic. Only understand logic. Logic translation. We translate HDL code into Boolean equation for each gate. Convert convert Boolean CNF. This step informs the equation into exact input format for set solver. Because CNF simplifies the solver job and makes the solving process faster. Consistent encoding. We add timming, timming limit, state restrictions, power limit, etc. Because hardware needs to follow physical rules, not just logic correctness. Set solver execution. Finally, the solver tells us unset isn't correct. Unset error. Set error exists. This entire pipeline is how modern chip companies verify million gate designs efficiently. Finally, let us understand why exactly 3 set is so important. Importance of 3 set in hardware verification. Why do companies like Intel, AMD, NVIDIA IA on 3 set for chip verification? Detects facility logic. 3 set catch incorrect combinations combination that might never be found by manual testing. Find insufficient signal state. Even if two signals behave correctly individually, they may fail together. Reset catch these rare instructions. Identifies bad gate instructions. Complex, uh, complex, complex circuit have thousands of gate connections. Three set verifies all of them mathematically. Advantages. Uh, Advantages. Reduce time and cost. Improves debugging efficiently. Used heavily in industries in short Reset is mathematically backbone of automated hardware verification. So this is the hardware verification. Three importance of reset in hardware verification. Thank you.